This is 10.3. We're moving on to different types of formulas. We have two more sets of formulas we have to learn. The one is called the double angle formula, and the other is going to be called the half angle formula. And we have a formula for for all three: the sine function, the cosine function, and the tangent function. And like I've been saying all along, the material itself is not that hard. It's just that we have so many formulas that we need here and that we need to know that it does make it a little bit more difficult because it's just a lot of formulas that we have to deal with. The math of it is not really difficult. So we have our double angle formula here, and this is what we're always going to use for the sine. Our cosine, the cosine has many different forms. It's equal to this, and then that is also equal to this, and then that's also equal to this, which makes it even more complicated. And then the tangent is pretty simple, not simple to remember, but it just has the one form that it has. So the idea is just to use these formulas in one direction or the other to solve what the problem is asking for. So in this first one, they're asking us to simplify 2 times the sine of 10 degrees times the cosine of 10 degrees. So you are supposed to recognize that this is going to be the sine of alpha times the cosine of alpha, which means our alpha is equal to 10. So that is going to be equal to the sine of 2 times 10, which is equal to the sine of 20 degrees. And that's what we mean by simplify, is just come up with the sine of 20 degrees. Okay, so very similarly, I want you to look at the one below this. I want you to try this one on your own. So go ahead and do that. In this one, you should have recognized that this is the cosine double angle formula. So here our angle, or our alpha, is 35 degrees. So we do 2 times 35 degrees for the double angle, which gives us cosine of 70 degrees. Okay, next one, moving on down, we have give us an exact value. So in this case, what's happening is you are still trying to recognize that we're using the double angle formula. This is the double angle for sine. So it's basically saying that this is the same thing as saying sine of 2 times pi over 6, which is the sine of pi thirds. And we should know by now that the sine of pi thirds is just the square root of 3 over 2. So that's it for that one. Okay, this one right here is going to be a little bit longer, and there's going to be a few like this in your homework. It says if sine of alpha is equal to 4 over 5, and alpha is from 0 to pi over 2, meaning it's first quadrant, okay, then we want to be able to find sine of 2 alpha, cosine, basically all the double angles. So what we want to do first is consider that we're in the top right quadrant, and then we have a triangle that is going to have the opposite side of alpha is 4, the hypotenuse is going to be 5. If you were to use the Pythagorean theorem here, we would find out that this side is 3. Now that we have all three sides, we can then identify that our cosine of alpha is equal to 3 over 5, and our tangent of alpha is equal to 4 over 3. That's just by using adjacent over hypotenuse and opposite over adjacent. So now what we're going to do is think about each one of these separately. So the sine of 2 times alpha is equal to 2 sine alpha cosine alpha. So now we know what each of these are equal to. So we have 2 times the sine of alpha is equal to 4 over 5, and cosine alpha up here is equal to 3 over 5. We multiply everything here together, and we get 24 over 25. So that's what sine of 2 alpha would be equal to here. Now we do the cosine alpha of 2 alpha. So cosine of 2 alpha is equal to, and we could choose any of the formulas above. I'm just going to go ahead and choose the very last one. And it doesn't really matter which one you do, but it's going to be 2 cosine squared of alpha minus 1. So that's going to be equal to 2 times, our cosine is 3/5. We've already done that. But we have to make sure we square this 3/5. So that's squared minus 1. So that will be equal to 3 squared is 9. 5 squared is 25. 9 times 2 is 18. So this will be 18 over 25 minus 1. And if we did 18 over 25 minus 1, we will actually get negative 7 over 25. Because this would be 25 over 25, 18 minus 25 is negative 7, and then the denominator stays the same. So now we go to the tangent. So the tangent of 2 alpha is equal to 2 times the tangent of alpha over 1 minus the tangent squared of alpha. And again, we're just going to plug these values in. 2 times 4/3 on top, 1 minus 4/3 squared on the bottom. So simplifying this, we get 8/3 on top, and we get 1 minus 16 over 9 on the bottom. Going to keep simplifying. 8/3 divided by, if we were to subtract this, this would be 9 over 9. That would be negative 7 over 9. And then when we divide fractions, we do 8/3 the top multiplied by the reciprocal of the bottom. That gives us 72 divided by negative 21. And if we reduce that, divide both of these by 3, we get negative 24 over 7. So again, the math there is still pretty easy. It's just about using the formulas and knowing what each of these things are equal to. Sometimes alpha will be given to us and we have to simplify what tangent of alpha would be. Sometimes they just tell us what the whole thing is and then we're simplifying fractions. So it's pretty basic math. It's just a problem of having additional formulas they have to deal with. So let's move on to the backside. I'm going to do something real quick here because it's really the same thing. There's no sense of us going through an example of every single one of these. You guys kind of get the idea of what we're looking for here. So here we're given a formula. We need to identify, first of all, that this is going to be the cosine. It's the half angle formula of cosine. The difference is that it's plus, so therefore it's got to be cosine because it's plus. Because we see what alpha is equal to 80 degrees here. So therefore, I can rewrite this as the cosine of 80 divided by 2. So it's just going to be the cosine of 40 degrees. So we're basically just identifying which half angle formula we're dealing with, which trig function, and then identifying what our alpha is so we can simplify. And really, that's all there is to it. I mean, we're just using these formulas over and over again. The same stuff we did in the first 2 sections is the same thing that we're doing now. It's just added formulas, which does make it kind of a pain. I get that. But at least the math is not that big of a deal. So I hope that most of this made sense to you, and I'll see you in class.